All right, so today we are talking about scale factor. Okay, so scale factor is when you have two shapes that are similar, one's smaller, one's larger. Scale factor is what tells you by how much the bigger shape is bigger or by how much the other shape is smaller. So for example, if you have a rectangle, a smaller rectangle and a larger rectangle, and let's say this side is 10, this side is 30, this side is 5, and this side is x. Okay, so I'm sure you can tell that this rectangle is 3 times bigger because 10 times 3 is 30. But if we didn't have such easy numbers, it would be harder to know just by looking at the corresponding sides. Okay, so this is how you find scale factors. So we've been practicing writing ratios with corresponding sides. So we're going to actually do that same thing. We're going to write a ratio. We're going to start with 30 over 10. Those are corresponding sides, 30 and 10. So that's our ratio. Now we're going to simplify. Okay, 30 can be divided by 10 to give us 3, and 10 can be divided by 10 to give us 1. That's as far as it'll simplify down to. So we know 3 over 1 just simplifies to 3, right? So in this example, our scale factor is 3. Now, we still have a missing side length, so we use this to figure out what our missing side length is. So if 10 times 3 is 30, 5 times 3 is 15, we know. Okay, so your scale factor is telling us how much bigger this shape is than the smaller shape. Okay, so let's do a couple practice problems. Now the reason our scale factor was 3 and it's because we started from our bigger figure and we looked at our smaller figure. So from our smaller figure to our bigger figure, our scale factor is 3. Now if we were to say, okay, how much smaller is the smaller one, our scale factor would be 1/3. We would be getting smaller by 3. We would be dividing by 3. So it kind of depends what in what way you're asking about scale factor. So let's actually do one practice one. We're going to have a larger triangle that has dimensions 14 and x, and our smaller triangle is going to have dimensions 2 and 1. Okay, so again, we're going to create our ratio. Okay, so we have 14 over 2. Okay, and if we were to simplify that, that would give us 7 over 1 if we divide by 2, which we know is just 7. So to get from the smaller figure to the bigger figure, 7 is our scale factor. If we were to go like this and say 2 over 14, we would get 1 over 7. So the smaller figure is 1/7 of the bigger figure. If we divide by 7, we get the dimensions of the smaller triangle. But if we multiply by 7, we get the dimensions of the larger triangle. Okay, so you can kind of see how it goes both ways. Let's try another one. We're going to do another with rectangles. Okay, a smaller rectangle and a larger rectangle. Okay, this side length is 10. This side length is 8. This one is 12, and we'll say this one's x. So now we can't really tell what the scale factor is as easily. Okay, so this is where you would need to, for sure, write your ratio. So 12 over 10. Okay, let's go ahead and reduce that. Okay, if we reduce by 2, that gives us 6 over 5. That's as small as our fraction can get. So 6 over 5 is actually our scale factor. Now let's make that into a decimal. 6 divided by 5. 5 goes into 6 one time. That gives you 5. Subtract, add a decimal into 0. Okay, 5 goes into 10 two times. So our scale factor is actually 1.2. So it's getting bigger by a scale factor of 1.2. Now let's see what our smaller scale factor would be. If we start with 10 over 12, start with the smaller dimension, that would give us 5 over 6. Now if we divide that, we get, let's see, can 6 go into 5? No. Add a decimal into 0. Okay, 6 goes into 50 8 times. Okay, 2, add a 0, bring it down. 6 goes into 20 3 times. Okay, and that's just going to be repeating, because if you add another 0, that gives you 20 again. So 0.83 repeating would be your scale factor from big to small. Okay, so we can do it either way. Now let's do one more example, and this can be another triangle. Smaller triangle has dimensions x and 12. The larger triangle has dimensions 30 by 60. All right, now to see how much bigger this shape is, start with the bigger dimensions, 12 over 60. Well, if you know 12 times 5 is 60, then you would see, if you reduce that, you get 5 over 1, which is a scale factor of 5. Now what would be the opposite? Scale factor of 1/5. Because if we were to start with the smaller dimension, we would get 1/5. Okay, so that's our scale factor. You can have a scale factor to the bigger shape or your scale factor to the smaller shape.